So my work is on what's called non-destructive evaluation. We use ultrasonic waves to characterize structural materials such as steels or concrete.
Yeah, my research area is in hazards engineering, specifically extreme loading of structures. So I'm looking at any kind of loads on a structure that come at a fast rate. This can be anything from a terrorist bomb blast to a vehicle impacting to a missile hitting a bunker.
Okay, so from a quality of life point of view, we're working in the area of characterizing damaged concrete. Concrete is a material that's all over the world. It's a relatively inexpensive building material, but it sometimes will deteriorate quickly. So we're developing quantitative techniques to determine, let's say, size, whether cracks are deep or significant in a concrete structure, and it helps in making decisions about whether you should repair or how to rehabilitate a concrete component.
My PhD dissertation was looking at if we could provide the military tools to predict what types of loading of vehicle bombs, so this would be a kind of a terrorist event, how we could decide what an appropriate level of standoff would be. So we did experimental tests and computational modeling to look at providing a tool for the military.
So the main research in my field now is basically the application of technology to the civil infrastructure. There's been a lot of technology developed for applications, let's say in the aircraft industry or the power industry, that haven't been adopted in terms of the civil engineering applications for civil infrastructure. There are a number of reasons for that. The civil infrastructure is very different, it's very large. The types of problems, the type of deterioration that's felt by bridges or buildings is very different from, let's say, the type of deterioration that happens in an aircraft structure. So we are working to take those technologies developed for other applications, let's say medical ultrasound, or let's say for the aerospace industry, and apply them for the civil infrastructure.
In the last decade or so, the U.S. has kind of changed the way we think of what types of loads are on structures. We often didn't think about blast being an important thing to consider when we had to design for multi-hazard, and now blast loading is becoming, sadly, the norm in engineering type design analysis. So we've looked at ways to implement blast into the hazard threat, as far as including it with earthquakes and wind loadings. And then also with that, we've had challenges with designing our structures to withstand different types of impacts. This could be from a terrorist threat. So my research has directly affected advancements in that area.